talking about the design of funds, the design considerations that we have to take into account are first, what should be the spacing between two bunds, then the cross section of the bund, right? Then we have to take into account the seepage. If you see, this is your one cross section, and this is the encountering water level. Then, in the proper design of any bund contour or graded bund, the seepage line. Water will enter laterally, and the seepage line or the wetted portion of the bund would be like this. And what a proper design says is this seepage line or it's also called phreatic line. This should pass through the base of the bund. If it pass anywhere here, or it should end within the bund. It will pass anywhere in the downstream side. What will happen is scoring takes place, and this bund will over the period of time will be damaged. So this thing has to be taken into consideration. This is something often which is not taken into account or disregarded sometimes. So another next important thing is in a bund design is the side slope. That is horizontal versus vertical. That is when you make the embankment, to make it more stable, you give a certain slope on the embankment. This is called the side slope. And the side slope will depend upon the type of the soil. If the soil is heavy soil, then side slope of half is to 1 or half 1.5 to 1 is to 1 would be sufficient. If it is a sandy soil, then 1.5 to 2 is to 1 would be suitable. And this 1 is to 1 or 1.5 is to mean means the general convention is horizontal versus is to vertical. That is 1.5 is to 1 means 1.5 horizontal. If we go 1.5 units horizontally, then the vertical fall would be 1 meter. So that is side slope, and this side slope has to also be taken into account. And what I was saying is, for different type of the soil, the side slope is different, and in fact it should conform with the angle of repose of the loose soil. By angle of repose means if you dump any loose soil, dry loose soil, it will make a heap. This natural heap of that particular soil has to be factored in. If you make naturally loose soil is dumped and is made to form a heap, what the angle of repose, what is this angle making? This is called the angle of repose. So this side slope, for stability, this should be taken into account. For sand it would be different, for silt it would be different, for loam it would be different, and for clay it would be different. For clay soil, generally the side slope is 0.5 to 1 is to 1. For loam, it is 1 is to 1. And for sand, it could range between 1.5 to 2 is to 1. And again, it will depend upon the type of the soil, whether the soil is alluvial, whether it is black cotton soil, or whether it is red soil. Like red soils are more stable. There for clay is a type of soil. In red soil region, we can have 0.5 is to 1 or 1 is to 1. So next parameter that design consideration one has to take into account is the freeboard or the free allowance. Like whenever you design a dam, you might have also studied in earthen dam, with some certain we will not fill the dam till the brim. A certain factor of safety is put aside, like that we call it as the freeboard. This is called freeboard. So that freeboard is that portion of the total height of the bund to which the water is expected to be impounding, where we keep that proportion we keep as freeboard, so that if there is excess rainfall, this freeboard will take care of it. Generally, bunds are designed for a rainfall or runoff recurrence interval of 5 years. Recurrence interval is the probability of any rainfall or rainfall excess to happen once in its time period. Here it is 5 years, so certain amount of rainfall which is expected to happen once in 5 years. So if we have freeboard, if in case, because it is probability, more rainfall may occur in a period of 5 years, more than the designed rainfall may occur, less than the designed rainfall may occur. If the rainfall, if we receive a storm of higher intensity, higher rainfall, then this freeboard will take care of it and will not allow the bund to be overtoppled. So this is the concept of freeboard. Now again, design consideration is the cross-sectional area. So what is cross-sectional area for this? This is a rectangular shape, length by width. So in case of bund, it is a trapezoidal cross-section, that its cross-sectional area has to be designed. So this is a trapezoidal cross-section, this is its top width, this is its bottom width, and this is the height. In fact, this freeboard will also be added to it. Freeboard is generally taken 0.25, 25% of the total impounding depth. That is 25% of the height. So this, since it is a trapezoidal section, the cross section would be, top width plus bottom width divided by 2 into height. That is its cross sectional area. So this way we can design the cross sectional area of the bund. Now coming to for any design, the rainfall or the rainfall excess has to be taken into consideration. The slope, prevailing slope of the land has to be taken into consideration. Then, the type of the soil and the texture of the soil should also be taken into consideration. By considering all these factors, first thing that we have to do in bund design is to find the spacing of bunds. By spacing of bund, we mean the difference in elevation as well as the difference in distance between two consecutive bunds. Suppose one bund is here and the next bund is at this place. This is your horizontal distance or horizontal interval, and the difference in elevation between these two bunds, this is your vertical interval. So design of bund also involves finding out the spacing between two bunds. How do we find the spacing between two bunds? By knowing the vertical as well as the horizontal interval. There are some certain empirical formulas, there are many formulas, but for the simplicity we will be discussing one formula. So to find the vertical interval between two bunds is given by formula S by A plus B where S is slope in percent. A and B, these are two constants depending upon the rainfall as well as the soil condition of the area. And this is a very generalized formula where this A is 1 by 10. The value of A is 1 by 10 for heavy and medium rainfall areas, and A is 1 by 15 for low rainfall area. So this equation for putting the value of A in this equation will get, and B, the value of B is 60 centimeter, and this Vi in this formula is expressed in centimeter. So for high rainfall area, Vi will be 10S by putting the value of A here, plus 60 is in centimeter, and for low rainfall area it would be, Vi will be 15S plus 60. This two formula you have to remember. And beside this there are two more methods of empirical formulas. One is given by Ramsey and second is given by Rex. Since it is a BSc agriculture course, had it been agriculture engineering course, we had to deal with all type of formulas. Here for simplicity we will be discussing only this formula, this general formula for finding the spacing between two bunds. So these two formulas you have to remember. Now once you find these are two bunds, this is horizontal interval and this is your vertical interval. When you know the vertical interval, you can also, and when you know the vertical interval, if you know the slope of the area, you can also find the horizontal interval, that is distance between two bunds. Say, suppose, what is vertical interval? We know what is slope, vertical interval by horizontal interval expressed in terms of, this is slope. And what is, say suppose in a high rainfall area, we have to find the distance between two bunds. Say it is high rainfall, then what will be the vertical interval? It is 10S plus 60. 10, suppose the area have a slope of 5%, 10 into 5 plus 60, that is 110, that is 1.1 meters. When we know the vertical interval, we can also find the horizontal interval. What will be the horizontal interval? This will be Vi into 100 by S. Vi here is 11, slope is 5. You can find out what is its horizontal interval. In this case, it would be 1100 by 5, something like 220 meters. So the distance between these two points would be 22 meter in case the vertical interval, in case it is high rainfall area, in case the slope is 5%. This way we can find the distance or spacing between two bunds if the slope is known. Now second is the height of the bund. Now see what is the height of the bund. Say This is, if we take out the section of these two bunds, here there is one bund, another bund is here. This is vertical interval, this is horizontal interval. In reality it will look like this. This is the horizontal interval between two bunds, and this is your vertical interval. So this is the one bund here, another one there, and say this is the ponding water that is impounding water, which is held against those bund. Its width would be, this is horizontal, its width is W, and its height is H. So what geometrical figure does it form? It is a case of a similar triangle. Right? By the property of similar triangle, we know that W by HI is equal to H by VI. Any doubt? Then W would correspond to H into HI by VI. Right. Now what is this figure? This is a right angle triangle. Considering that if we over a longer length, we disregard the side slope. Like in actual figure, it would be like this. Here there is bund, here there is another bund. This is the impounded water, and this is your vertical interval. This is the height. So this portion we are taking it as a perpendicular line, just for the sake of calculation. Then how much water will be stored in this section where the impounding will be there? That is a half base into height, half into W into H. Any doubt? If we put the value of this W here, it will be like the amount of water stored would be half into H into HI X by VI. And what is this impounding water? What is this impounding water? If we compare this impounding water with the rainfall that is falling, that is the excess rainfall. So we are not concerned with the total rainfall. In fact, we are concerned with the excess rainfall. The excess rainfall which is coming here, the volume of excess rainfall per unit length will be RE into HI. HI is distance spacing between two bunds into 1, that is unit length. So if these two volumes are compared, then we get height in terms of HI will get cancelled. So H square will be 2RE into VI, and H will be under root 2RE VI. What is this RE? RE is the rainfall excess which this bund is supposed to store. So we can find the height of the bund by this formula, where RE is the rainfall excess VI is, this is in meter. Vertical interval, that is vertical spacing, and H is height of the in meter. So whenever there is some problem based on this height or cross-sectional area of the bird, we have to find the height through this. Where RE, the concept of RE is, here what we have considered is, if rain is falling, which does the total rainfall which falls on this area will form this impounding water? No. The rainfall excess, that is extra amount of rainfall which result in runoff will be stored here. So this we have converted in terms of height. So these formulas you have to jot it down somewhere, and whenever there is a numerical based on it, you have to do it. Third is the cross-sectional area. This is for a bud, whether it is contour bud or graded bud. This is the top width, and this is your bottom width. And this is your side slope. Z is to 1. Yeah. Can write horizontal is to vertical. Now we have to find the cross-sectional area of this bud. So cross-sectional area of the bud would be, since it is a trapezoidal shape, top width plus bottom width divided by 2 into height. What is height here? This will be the impounding water. This is your total H. This is the height of the top level of water surface, designed water surface. But in this height we have to add the freeboard as well. That is 0.25 H. So this cross-sectional area will be top width plus bottom width by 2 into H plus 0. Or we can write 1.25 H. I hope it is clear. So this way we can find out the cross-sectional area of it. The thumb rule for cross-sectional area is, like the top width for Indian condition should at least be 0.5 meter, and bottom width should at least be 0.2 meter. Otherwise we can calculate through the formula, or if you have to follow the thumb rule, then top width 0.5, and once you know the top width, and if you know the type of the soil and the rainfall condition, you can decide upon the side slope. Once this side slope is known, you can find out the bottom width as well. Suppose this is the top width, the depth height we know, then say it is 1:1 means the total depth will be 1 meter, and this 1:1 means this will also be 1 meter, and this will also be 1 meter, and this is say 0.5 meter, then it would be 1 plus 1 2 plus 0.5, that is 2.5 meter. So this way you can also complete the cross-sectional area of the bud. Now next thing in design is your contour or graded bund, the total area lost as a result of contour bunding has to be factored in, has to be taken into account. And this is one of the major constraints for contour bunds, because there are certain area, contour or even graded bunds or field bunds, there are certain area which is lost due to the by forming the embankment, although not very high, but it is formed, and it may affect the farmers. So farmers normally is not very much interested in bunding, especially for contour bunding, because contour bunding is not a straight line. It may impede with the field boundaries. So the area loss can be found out by, you can find out the length of the bund. How do you find out the length of the bund? Length of bund is per hectare, if you have to find out. Length of the bund per hectare, 1 hectare is 10,000 meters by horizontal interval. If you know the horizontal, find out the horizontal interval, then the length of the bund can be found. What does length of the bund mean and what is its unit? Its unit is running meter. Say this is a 1 hectare piece of land and you are doing bunding. So the length of the bund will include this length plus this length plus this length plus this length. That means this is your horizontal interval, and total length would be the total area. In this case, unit area is 1 hectare divided by the horizontal interval. So then we can find out the length of the bund. What is horizontal interval? We have previously found out Vi by Hi is equal to, it's not necessary that all the time you remember the formula, it can be derived that way. Very simply, if you know the fundamentals, physics, so Hi is 100 Vi by S. So this will be, Hi is 100 Vi by S. So it will become 100 S by Vi. If you know the slope, you can find out the vertical interval by that general formula, depending upon the rainfall, 10S or 15S plus 60. Then you can find the total length of the bund by knowing the horizontal interval. Now, if you have to find this area lost because of bunding per hectare, so this is your area, and because of these bunds, obstructions made at certain interval, this much of area, that is the base width of the bund, is rendered useless, because there you are making an embankment. Although it's another thing, you can utilize it for by growing fodder or some leguminous crop, but theoretically this portion is lost as area lost. So what will be the area lost? Area lost will be equal to length of the bund into your bottom width. This is your bottom width. This is your total length. This plus this plus this and this bottom width. So this is the total area lost because of bunding. So what is length of the bund? We have found out. It was I think 100 S by area into bottom width. So this way we can find out what is the total area lost because of bunding, and what is the earthwork also we can find out. Earthwork, if you know the length of the bund and if you find out the cross-sectional area of the bund, then we can find out how much is the earthwork. Earthwork means for constructing this bund, how much soil has to be excavated and put in the embankments, because that will decide the cost of the bunding, because for digging the soil or excavating, manpower or JCB is required. So they normally charge in volume terms. So if you know total length of bund and cross-sectional area which we have derived previously. Then the total earthwork will be the total length into cross-section, it will be in cubic meter. So this much CFT or this much cubic meter of soil is taken out for this type of activity can be. So these are some of the basic things in design of bund. We will try to understand this design of bund by one or two problems. Say the problem is on a 3% land slope, calculate the HI or horizontal spacing of bunds in medium rainfall area zone, and also find the length per hectare and earthwork involved. How to go ahead with this problem? What is given? S is given as 3, right? 3%. HI we have to find out. Then we have to find out length of bund and earthwork. So the general formula for VI is, for this is medium rainfall area. So VI will be here 10S plus 60 in centimeter, right? S is given as 3 plus 60, that is 90 centimeter equal to 0.9 meter. Then once VI is derived, then we can find the horizontal spacing as HI. HI will be 100 S VI. We have already derived this. So 100 into S is 3, VI is 0.9. So it will be in centimeter only. 300 by 9, whatever it is, say 31, 33. Right. So this is the horizontal interval between 133 meters. Now once VI is known, once HI is known, horizontal spacing is known, we can find the length of the bund per hectare. So the length of the bund will be per hectare will be 10,000 by HI. What was the HI? HI is 33 meters. 10,000 by 33. It will come out to be 333 something meter. It is in 1 hectare land we have to consider. According to this given data, we have to construct 333 meter of running meter of. It will be running meter because it will be a addition of all for the individual bunds. So this is 1 meter. So this running meter means this length plus this length plus this length. Now we have to find what we have asked, length per hectare, then earthwork. For finding the earthwork involved, you will require 333 meter into the cross section. So for cross section, you have to again find out the cross section of the area that you have to do. Then you can find out how much cubic meter of earthwork is required for this one. So this I am not going to do it here. You, according to the method told to you above, previously, you can find it out. One more question that will make you understand things more clearly. Calculate the height and cross section area of contour bund to be constructed on a land slope of 5%. The other details are, one, rainfall excess for 24-hour duration equal to 100 centimeter. 2, horizontal interval is equal to 10 meter. This is 1 meter. You must remember one thing, these contours are always designed on 1 day excess rainfall. That means it's designed for a recurrence interval 5 years, that is the probability of a certain rainfall in a day crossing a certain amount. So it is designed for 1 day excess rainfall, not total rainfall, excess rainfall. What is excess rainfall? The rainfall which flows as overland. So 24 hours 1 day excess rainfall is 1 meter and HI is 10 meter. Here you have to find out what are the height. You know the formula, H is equal to under root 2 RE into VI. And what is RE? RE is the rainfall excess in meter. And we have been given HI. If we know HI, we can find out the RI as well. And slope, we know that HI equal to S by 100, the basic equation. So we have to find the VI. So VI will be, HI, that is 10 into slope is 5 divided by 100, that is 0.5. So this will be 2 into rainfall excess is 1 meter, 1 into 0.5, that is under root वन जो भी वैल्यू आता है that will be your height of the bund. So what is under root 1? I have to find out. So say it is 1 square meter, but this is the only the height of the impounding water. This is the height of this. यहाँ तक आपका पानी है. This is this height. But you remember I told you we will have to take into account the freeboard. This portion freeboard. The freeboard is 25% of H, right? So the freeboard has to be taken into account. So the total height will be total H will be 1 plus 0.25, that is 1.25. So the total height of this environment should be 1.25 meters. That is one part of this question. The second part, what was the second part? Cross-sectional area. Cross-sectional area, that is top width, bottom width, and this height has to be taken into account. If in this case the side slope is not given, then we can go for the thumb rule. The thumb rule says the top width should be at least for Indian condition 0.5 meter, and the bottom width should be 2 meter at least, and the total cross-sectional area should be not less than 1 square meters. This is we are going with the thumb rule just because the side slope in this question was not given. Had they given the side slope, then we had to find this bottom width, and the height is already we know. Bottom width and total cross-sectional area we should have calculated. So cross-sectional area would be 0.5 plus 2, it is 2.5, it is 0.5 top width plus bottom width by 2 into height is 1.25, that is 2.25, 1.25 into 1.25 will come around something around 2. Don't know whatever it is coming. So this will be the cross-sectional area of this. So this way we can find the cross-sectional area. If places where the side slope is given or VH2, we can also find out the bottom width based on height and top width. So this way we can design and solve problems regarding contour graded bunds. And there are many other things like alignment of bund that I won't be telling you here. Go through certain books or literature, you will find it. And there will be many more questions related to bunds. And bund is one of the very important agricultural structures, cost-effective agricultural structure for cultivation in the agricultural field. So that's all from my side. Thank you very much.